Presentation up. Did I get confirmation that you can see my slides?
Yes, we can.
Okay, let's get started. Oh, let me switch my screens. Okay, so good day, everybody. I'm going to talk today about beyond 400 gigabit per second Ethernet. Yes, that hasn't hit the mainstream market yet, but we're already looking to the future to go beyond 400 gigabit per second. Just to give you a little bit more into my background, I have chaired a number of various efforts in the IEEE. Currently, I'm chairing two, the study group effort for beyond 400 gig Ethernet, but also looking at bringing 400 gig Ethernet to DWDM systems. In addition, I have also chaired the last two groups that speeded Ethernet. So I was given the task a long time ago to take Ethernet beyond 10 gig, and here we are later, 20 years later, talking about 800 gig and 1.6 terabits. So it's been a really interesting ride for me over the past 20 years. Before I get started, I should note that while I'm a chair in the IEEE 802.3 at per the IEEE Standards Board bylaws, anything I'm saying today is my own opinions, and I'm not here as a representative of the IEEE. Okay, so I heard on the last speakers talking a lot about online education, and this has been one of the things that really has led to what we call a bandwidth explosion. And a long time ago, the 802.3 Ethernet Working Group realized that it needed to monitor what was going on in the industry with bandwidth. And we've done these reports previously where we looked at it, and essentially what we found was that bandwidth can be attributed to three factors. Okay, so an increase in the number of users, an increase in the access rates, and then an increase in the services. So let me go through this a little bit easier. So the users is very obvious. As we bring more people onto the Ethernet or onto the internet, there's more bandwidth being consumed on a per base usage. But if you were to look at how people are accessing the internet, it's not just that they're being offered faster ways to connect to the internet, but they're connecting to the internet in different ways. We always talk about these phones that we have. 20 years ago when we started this, they weren't around. Today, they're a main driver. And then by services, we're talking about all of the different software packages that are out there. Any one of these three can cause a bandwidth explosion, but when you combine three together, then you really see the bandwidth demand that we're dealing with today. Now, as I said, the 802.3 Working Group's been doing a lot of work on this over the past few years. I've listed a couple of URLs down there if you want to see the latest bandwidth assessment that we did. There's a full report. It's about 60 pages, I believe, as well as a tutorial that will go into all of this in much greater detail. But let me jump to really what the findings were. And it's very simple. We looked at a number of different applications over the past several years. And then we looked and projected it out into 2025. So this report was completed last year. So we did a 5-year kind of assessment. And what you can see is that the bandwidth is growing across applications anywhere from 2.3 to 55.4 times what the normalized traffic would be in 2017. And while we have to normalize it to bring everything into scale, I'm sure you can understand how great the data center capacity is. The amount of traffic that these organizations are driving is just incredible. So in order to support all of this and to figure out what's happening, we look at the growth rates and we normalize all of the data. And when we looked out at 2025, and the reason why we chose 2025 at that point is that we thought that would be an estimate for when we would actually complete the next speed. What we see is that 800 gig Ethernet would barely be keeping up with the demand at that time. 1.6 would still be clearly only keeping up. 1.6 terabit would only be a 4x increase over the 400 gig that was introduced in 2017. So we really had to get started, on deciding to get the project going, and then figuring out what the speed is and what are all the different aspects to the new Ethernet that will come out for beyond 400 gig. So the first part in a 802.3 process is that you form a study group. And in the study group, you essentially define what the project is going to do. And you justify that through, we have to complete what's called a criteria for standards design. And when we brought this case forward, we were given a very unique charter for a next speed project. In this case, you can see in the first bullet for the scope that we will be looking at beyond 400 gig Ethernet. But additionally, and this is one of the interesting dynamics that's changing in infrastructure in the world today, we were also given the charter to look at using any of the technologies that we develop for beyond 400 gig to existing rates. So I'll try to explain this real simple. Imagine that we're going to do 800 gig Ethernet, and we will develop 800 gig Ethernet, for example, based on 4 lanes of 200 gigabit per second signaling. We were given the charter then to apply this 200 gig signaling to existing Ethernet rates, such as 200 and 400 gig Ethernet. So it's really a very unique charter for a group of this type. It's the first time that we've actually ever done something like this. If you're interested in more activity on the study group, I've listed the web page there that you can go to, and please feel free to join the reflector. Okay, so the first question as I just raised is, well, what is the next speed? Is it 800 gig? Is it 1.6? And this has been a very unique charter, a very unique question. In the past, Ethernet, I know we have a lot of students who are here. They may not know, which seems so odd. I feel like I'm dating myself. A long time ago, Ethernet always used to grow by factors of 10. Started off at 10 megabit, then 100, a gig, and then 10 gig. And then after that, it started to change. With the 10 gig project, we introduced 40 and 100. And then instead of jumping to a terabit after coming up with 100 gig, we jumped to 400 gig, and then we included 200 gig. So there's a lot of various Ethernet rates out there today. But when you look at this chart, what you see that with the trend over the past 3 speed increases, so specifically 10 gig, 100 gig, and 400 gig, you can see that the standard was completed really before the projected need. Well, I shouldn't say projected need, before it was actually being put out into the industry. And part of the reason was it took time to develop the technologies to meet the industry demand. Now, when we look at 800 gig and 1.6, it's very unique here. And you can see that 800 gig, when you look at this plot compared to where that dotted line is, 800 gig is late. And 1.6 terabit, well, that looks to be a little late, but it also seems to be right on time for when that demand is going to be there, relatively speaking. Okay, so this is one of the issues that the study group has been dealing with in terms of, do we actually jump in and do both of these speeds? And it's a very challenging question. We'll touch a little bit more on that throughout the presentation. Now, you may say, why do we keep needing all these speeds? And I already talked about the hyperscales. There's a lot of money that the hyperscale community is putting into their data centers. And the chart on the left is just the US hyperscalers. This is data that I got from the 650 group. But you can see the company CapEx, but then you can see the amount of money that's going into the data center equipment. And you can see it's a substantial amount. But why? Well, if you look over to the right, this is the forecasted revenue. And I think, from my own perspective, a long time ago, I used to think about data centers as more the social media, all of the applications that I didn't really put a name to. But when you start to look at the various things that are generated in the cloud, the co-location, the infrastructure as a service, software as a service, search and social, you can see that there are actually a number of different applications that are growing that they're investing in. It's kind of mind-boggling when you think about the cloud revenue, as it's shown right here. It exceeds the Swiss GDP, 19th in the world. That's just a mind-boggling chart. So there is a financial justification as to why people keep investing into this. And so, I think the opportunity, listening to the last speakers talk about, the students and the opportunities, I think it's really important that everybody appreciates in today's digital economy, there's a lot of different things that are driven out of the data centers, a lot of various application spaces, and a lot of those data spaces are built on Ethernet. So it ultimately comes back to us to keep providing them with the pipes that they need to build the data centers of tomorrow to meet out all of these applications. Okay, so when we look at a typical Ethernet network, and one of the things that this chart actually generated is the fact that when we look at data centers, there's a lot of different architectures that are out there. So consider this figure on the left to be more of a general figure to talk to, and recognize that there are a lot of different architectures from different companies that are out there. This is more of a high level view to try to put in, what are the various mediums that we will need to worry about, and what are the different speeds. So down at the servers, a lot of that, people are starting to look to move beyond 100 gig. And a lot of these connections are very short. I've listed 30 meters there. In truth, there are applications that are using copper cables that are a meter. It all comes down to the cost, but there are people who do different approaches, companies that do different approaches, and you see that happening. You then have the top of row, middle of row leaf architectures, 400 gig, 50 meters to 500 meters, looking at either multi-mode or single-mode fiber, and duplex or parallel fiber. Up at 400 gig, we move into the 500 meters to 40 kilometers on a duplex fiber, and then in what we call the DCI, the data center interconnect. So basically an interconnect to connect data centers that are spread geographically apart. That's an 80 kilometer reach, at least 80 kilometers. And right now we're at 400 gig being developed. That's actually in the CW task force. So as you see that there are a lot of different parts to the data center networks that Ethernet provides solutions for, and there are a host of different solutions. There is simple twin-ax cabling, there's multi-mode fiber, single-mode fiber, there's parallel combinations of them, and then there's DWDM. A lot of different things, and Ethernet keeps growing and coming up with different ones. When I look at this, the DWDM is actually the latest entry into for Ethernet. We actually completed, the 802.3 CT project, which is doing 100 gig over DWDM. So that was actually just published this past Friday. So Ethernet continues to expand into new application spaces. Now, there's a lot of stuff that's going on, and when we try to make sense of it, we do look at the fact that, where do we need to spend our resources? Where are some of the priorities? What does the market need? And in this case, this is some data that I got from an optical analyst, light counting, and we looked at all of the various combinations that people were using to address different reaches. And you can see in this chart how prevalent 500 meters is in terms of the Ethernet optics that are out there. 100 meters is growing, and this will grow as we get to more of the 200 is based on a 50 gig language, and 400 gig today is based on 8 lanes of 50. There's work underway to go to 4 lanes of 100. So I would argue that as we get to that 4 lane of 100, that's where you're going to really see this type of growth. In addition, the 2 kilometers plays a very important part also. A lot of times it's, we talk about these reaches, but it really comes down to the loss budgets. So that 2 kilometers is often used in a lot of the campus applications, and actually in a lot of the data centers, which are actually that large, combined with a little bit more loss associated with the infrastructure in it. And then even 10 kilometers, you can see is becoming it's not a huge number in terms of the percentages, but it is very important to the overall network, as well as the 40 kilometers, which then starts to expand into different markets, and then the 80-kilometer DCI interconnect, which is a very important part, because data centers essentially are, I guess the best way to say is that sometimes they just become too big, right? The trying to source all that power in one location and have it all centralized in that one location, especially in the U.S. where real estate becomes an issue around these sort of locations where you can provide that sort of electricity. The 80 kilometers is actually becoming a very important part of the reach, even though it's not as many links. So there's a lot of information that's being gleaned here in terms of where to put our priorities, but with the understanding that that doesn't mean that the other stuff isn't important as well. There's also been a very big change in terms of what are the form factors that people are looking at. And I'm going to talk in a few minutes here, actually next slide, about how a lot of the Ethernet speeds going forward are not based on a single stream. There are some applications where that happens, but a lot of the applications today are, the sweet spot, as we call it, is often based on 4 lanes of a given rate that basically aggregate up to the higher speed. Going back to my earlier example, 4 lanes of 200. Okay, so 4x used to be a very big sweet spot. Actually, in the last decade, it was a huge sweet spot with the introduction of 40 gig with the 4 lanes of 10 gig, and that really started a lot. But now, as time has moved forward, we have seen this transition to these form factors that can support 8 lanes. And by 8 lanes, I'm talking about the electrical input into them. There's lots of things that happen optically then. With an 8x lane, what you can do is you can support a higher density based on these single lanes. You may do in some cases, a by 2 type of solution, or you may do a by 4 solution. So it's been argued that a lot of this 800 gig Ethernet isn't really 800 gig Ethernet, but is 800 gigabit per second capacity, where 2 400 gig ports are being put into this form factor. So it's a kind of a changing dynamic that we're really trying to get our arms around, because it's not really about single rate Ethernet anymore in a lot of these switches. A lot of these new switches that are being introduced are actually multiple rates, and I'm talking up at the much higher speeds. Okay, so this is the chart that I was talking about. It's a very simple math. Okay, it used to be that we always talked about when do we get to a single lane, because a single lane is really that tends to be where you see a lot of the high volume, with the exception of DCI, which will not be. It'll be a single lane of sorts, but let's drop that for a second. So, for example, as I was talking about with the 4 lanes of 10 gig and 40 gig. That's how 40 gig really became popular. When I talk to a lot of telecom people, they say what a failure 40 gigabit was. And I'm like, no, not really. Maybe in the telecom space, but when you look at it from a data center solution, it was quite successful. The number of optical modules sold to support 40 gig were incredible. And it really started us down this approach where it's not just a single lane that we worry about, but it's multiple lanes. And then you combine that with what is ever the highest rate per lane that you can achieve. And that's kind of how Ethernet has moved forward since the 4100 gig. Yes, we have been able to come up with some serial lane rates. We did do 25 gig, 50 gig, and nowadays we're working a lot on 100 gig. And you can see these families then that they support for a 1 lane solution. When you start off with 100 gig, the electrical interface actually started off at 10 lanes of 10 gig, right? So you get the idea here is the number of lanes times the rate per lane. Now, when we jump out to 800 gig, you can see I just talked about how we're developing a lot of technology around 100 gig. This 8-lane interface, 8 lanes, 100 gigs, gives us 800 gig. And if you really wanted to go wide and that was acceptable for you, you could do 16 lanes to get to 1.6 terabit. I would say that we're seeing a transition nowadays from 4 lanes to 8 lanes, as I just talked about. But with some of the new packaging techniques, specifically chip-on-board optics and co-packaged optics, there are now being cases made that we should also be worrying about 16-lane solutions. I think a lot of us are, we're used to this 4-lane mentality, so it's going to be kind of a switchover where we have to start expanding our thinking to 8 lanes. But you can see how between 100 and 200 gig signaling, we will be able to address these higher speeds of 800 and 1.6 terabit. And that's kind of the discussions that are happening right now. But in addition, and I want to point this out, as we develop 200 gig signaling, we'll also be able to address a single lane to address 200 gig Ethernet solutions, as well as 2 lanes of 200 gig to support 400 gig Ethernet, which is actually a really important thing because in order to get to higher density, I would say it's going to be a while before we ever see the 400 gig electrical signaling. Probably not in my lifetime. So for you kids that are there in the student age, this is where the future is really going to be. When I look at 200 gig signaling, I expect that to be implemented and deployed by 26, 27, and probably 5 years, 7 years after that, people will be saying, "Oh, let's go to the next speed. And how are we going to get to 400 gig signaling?" So I see 100 as being around for a long time and 200 being developed and in its initial stages. So as just kind of a brief summary here real quick of what we just talked about. We're moving away from these single lane, single rate ports, or actually just single rate ports. And really there are now multi-rate ports where the switches can support 1 lane, 2 lane, 4 lane, 8 lane implementations. And you do that with whatever the respective rate per lane is, and that's what you figure out what the Ethernet ports are. And that's what we're developing our PHYs on, 1, 2, 4, and 8 lanes. And we're seeing this market acceptance. This project is actually looking at that very importantly, and one of the discussion points for it has been that we should be looking at developing solutions to support this 1 to 8 lane multi-rate port, especially as we start to look at 200 gig signaling, because we're going to have to move away, or we will probably move away from the kind of Z-axis pluggable modules of today into other technologies such as the co-packaged socket that I'm showing down here in the bottom figure. Okay, so this is a lot of discussion, and it's not a question of is the industry going to do it, but when will the industry complete all of this and make it commercially viable and reliable enough that we can see that type of deployment. Okay, so for those who are thinking, well, what does this mean to me? How do I get involved? Where do I get involved? There's a lot of different places when one looks at developing an Ethernet solution for possible work. First of all, forward error correction. So coding is a very, very big deal, especially with this new architecture and as we get up into these higher signaling rates. The electrical interfaces that we will develop to support all of this stuff will be a lot of work. All the optical and electrical PMDs, so the actual signaling that we use, and then also the media. And I think this is a really important point to note as well. The media continues to grow, it continues to expand into the number of different variants that Ethernet actually addresses. And there's a lot of opportunity in all of this stuff as a way to move forward. Now, I'm not going to go over this in detail. This is really just for your perusal afterwards. These are all of the different objectives so far that the study group has adopted. Now, what you'll see here is that we are actually going to have project goals related to 200 gig Ethernet, 400 gig Ethernet, 800, and 1.6. Now, let me jump to this chart right here, which is a better way to look at it to give you a quicker, easier summary. In general, there's going to be a lot of 200 gig development. We will leverage a lot of 100 gig, especially for electrical interfaces, for 800 gig multimode fiber solutions, and then parallel fiber solutions. But then 200 gig is all over the place. We'll be using 200 gig to address all 4 rates. We'll be using 200 gig to deal with things electrically and optically. And we will also be looking at, you'll see down here, there's for 800 gig, there's a TBD. That's really to address the 10 and 40 kilometers. And this is where some of the advanced modulation techniques, coherent signaling, for example, that's typically been used in the telecom space. This is where we expect to see some of this new technology deployment happening. So this will be an interesting part of this project. So you can see a very, very big project. There's still some work that's being discussed. Some people are talking about 1.6 terabit based on 16 lanes of 100 gig. I guess I could have, well, I have it as a question mark because we haven't made a decision yet about it. And then people are also talking about doing copper cabling. Please consider this chart to be a point in time. So whether copper cable gets into this project or not, from an Ethernet perspective, it's not always about getting into the first project. We tend to have, the picture that I'm showing you right now is really a good representation of the Ethernet family. And it eventually usually does get filled in with the solutions for a given rate. Touching back again on the 16 lanes of 100 gig, part of the reason why people are talking about doing this isn't necessarily for deployment in real systems, but is for developing test equipment. So, if you want to have 1.6 terabit test equipment available in 2027, you're going to need to use more of existing technology than the technology we're going to develop to basically do a lot of the troubleshooting and testing. So I think that one, we can probably well expect that to happen. Okay, so going forward, as I touched on real early, 800 gig is late. People needed that years ago, actually. We've actually had people, the hyperscalers come in and talk about it in the 2022, 2023 timeframe. I can assure you that we won't turn around an Ethernet standard that quick. And I'll touch on something else in 1 second. 1.6 terabit also needs to be considered now, so it won't be late in the future. Now, the key point here is that this 800 and 1.6 is really based on solutions that are either going to be 100 gig based, 100 gig per lane, or 200 gig per lane done. So we actually need to look at a lot of this stuff simultaneously in order to develop the right solutions to be done across all of the different speeds. If you start up front before you've defined anything, it's usually a lot easier than going back to add stuff in. So we have to worry about, for example, an 8x100 gig Ethernet solution or a switch on one end being able to talk to a 4x200 gig solution on the other end. There's a lot of different work that goes into that. Next, the industry is adopting these by 8 form factors. So it'll be something that we do take care of and think about there. 200 gig signaling is clearly very important, as I've touched on, as is the coherent. Now, I don't have a complete timeline yet where I can tell you. What I'll say is that when we started this effort, we assumed it would be a 5-year effort. We're in year 1 right now, and we expect the first task force meeting. So this would be where we start to make technical decisions to happen in January of 2022. So 5 years from now, we'll be looking at roughly 2026 for when we would expect this new standard to be done. So with that, I'd like to thank everybody for the time, and as well as the opportunity to give you an update on where the latest on this effort is. Thank you.
Much thanks, Mr. John, for this presentation. A round of applause, please. Uh, I now understand why you are called the Ethernet evangelist. Uh, I can say that my biggest takeaway here is that there's a lot in the digital economy which requires Ethernet. And I've gotten even interest in the copper cabling in regards to the Ethernet. I've gotten so much interest in this, and I'm sure many of us participants are feeling the same. I can see quite a quite number of questions. Maybe I can read them to you.
Okay, so just open up the chat
Mm,
window and you can start me off where you want me to go.
yeah, I'll just start from Hello Sir. Hello Sir, we can see these speeds outside of data. Huh? Where can we see these speeds? When can we, when can we see these speeds outside of data centers?
Good question. I know we tend to focus in a lot on data center because of the obviously the money that goes into them, but in reality, Ethernet is being used in a lot of other places as well. 200 and 400 gig is already making its way into the backhaul networks, and with 5G deployment, there is a lot of concern in areas that the aggregation of all that data that 5G will bring will overwhelm those backhaul networks. So I would anticipate that we would see a lot of, I'd say, initially the 200 and 400 is when um, is what we'll see first in those networks. 800 is out there. I would say probably more because we have to develop it. Um, the 1.6, I think the 1.6 really, when you look at what we're talking about in terms of the solutions that we're going to provide, 1.6 today is really being envisioned as an upgrade path that we develop now for data center networks. So I would say the 400, jump back for a second. So if I were to look at just this summary slide right here, it's this 10 and 40 kilometers that is going to be outside of these data center networks and particularly in the 5G. So that's a lot of development work. We have been able so far, as I said, we just developed and standardized the 100 gig Ethernet over DWDM systems, and that was using coherent signaling. Um, there's a lot of debate, and I think a lot of people are expecting. You may have heard the term coherent light. They're kind of thinking that we're going to use some sort of coherent solution, and I can tell you as chair of the group that's developing the 400 gig coherent, getting that to a multi-vendor interoperable spec is proving challenging. So I don't know at this point when to expect 800 actually out in that space. I think this will be one of the longer development portions of the project.
All right, thank you for that. Maybe we can hear for another question. From the data center infrastructure point of view, how does upgrade of 100 gigabytes per second to 200 or 400 gigabytes per second affect other resources, especially computing and elasticity of the processing resources?
Good question. Um, and I would say that this is tied into a lot. I heard a lot of discussions before about AI, and um, I won't say I have in-depth knowledge of AI in the data center simply because this is a new area of development and people are trying to figure out how to do this stuff. The way that I have seen AI being deployed is in the traditional networks, you had servers connect to a switch, and then you had switches connect to each other. And you basically had to go up and down the network to get from one server to another server. What we're seeing in some of the networks that are being deployed is basically servers are connecting to multiple switches so that they're able to reduce the jump down, the latency, because they only have to go through one switch hopefully, as opposed to a lot of switches to get to the other server in order to move the data quickly. Now, the question that was asked is, okay, well, how does that affect the progression? I think what we're seeing is that this stuff is so new that a lot of people are trying to figure out how to do a lot of this stuff. And I see a lot of people now, when they look at, maybe a 400 gig switch, that there may be 16 lanes of 400 gig server. That's usually like the top speed that it's capable of. But a lot of these servers now are, once again, the they're using that packaging approach to do a lot of interconnect so that they can take one server and, let's say, the 8 lanes of 100, they can go to 8 by 100 to spread things out quickly. So, if I were to look at this from a server perspective, this approach will last, but we have to recognize that the serial lane signaling development is slowing down. Okay, so how much packaging we can do to enable a multi-switch connection from a server is going to play a very interesting dynamic. So it's that's with the assumption of a single lane. The reality is that maybe some people will go to 2 lanes, and they'll figure out whatever solution works. An interesting thread, and this is the other thing that we're trying to deal with, is prior to there's a fascinating paper that was presented that, if you look at going out to 2012, Moore's law had computing capability doubling every 2 years. Data that was presented in this paper then showed that from 2012 on, the demand for processing caused by AI machine languages was doubling every 3 months. So our ability was only going once every 2 years, but the demand was doubling every 3 months. So it really is going to put a lot of pressure on the infrastructure people to keep up with that sort of thing. And given how new it is, it's going to be fascinating to watch how that evolves with the infrastructure and all of these different rate choices that one has to play with.
Thank you so much, John. Maybe we can answer 2 more questions and then we wrap this up.
Okay.
The next question is the 200 gigabytes per second signaling rate a standard, or can we improve it to be maybe 800 gigabytes per second?
Oh, I love people when they keep asking these questions. Let's get something done first. The reality is that we are in the process of finishing up 100 gig signaling. Okay, and that's all based on, for the electrical people, something called PAM4. Okay, so essentially 4 levels. There's already discussion in moving to 200 gigabit per second signaling to go to PAM6. Now, when you start to talk about, oh, maybe we can go to 800 gig, the answer is yes, we may do that for certain applications. The 10 kilometer and 40 kilometers, that is something that could very well go to a serial stream, and maybe that would be 800 gig per second signaling. But I would say to that individual that you need to recognize this presentation in its totality and not just look at the signaling rate. As I said, a lot of the applications that are out there are being used not for their highest speeds, but are being used in a multi-rate port configuration. Doing 800 gig signaling over a parallel fiber approach, that sounds great in the future, but the demand isn't necessarily there. That will be something that, when the time comes, will probably happen, but not at this point in time, where people are looking at this parallel fiber approach, where they can basically, we do something called breakout. And what they do is they take the 4 parallel fibers and they may run them together, or they may break them apart and spread them out. So the demand throughout the entire ecosystem of that network needs to grow to that point. So you really need to ask the question, what physical layer are you talking about when you start talking about the signaling, and what is the application for it?
Thank you so much, John. One last question. Well, this is actually a request. Maybe you can send us this presentation so that we can go through it and be more interested in the topic.
Yes, absolutely. I actually did send that late last night. My apologies. It's been a kind of a hectic week here, but I did send the PDF of it. And as I said, there are points in here that you can clearly go to and join. And I will actually put as soon as I get over to the chat window, I will put my email address in the window. Anyone is welcome to, whoops, misspelled it. Sure I get it right this time. I'll be happy to answer any questions and direct you to those resources if you want to get involved or monitor.
Great. Thank you so much, John. So we really appreciate maybe a round of applause as we finish up. Thank you so much. Yes,
Thank
thank
you,
you,
everyone.
thank you. Okay.
Have a great day and enjoy the rest of your session. Goodbye.
Goodbye. All right. Great, great, great. Thank you for all your reactions. In the interest of time, we will not have an extension of break. We will just get right into the next session. I will now introduce you to the next speaker of today. He is the chairman of Technology and Science Education in the University of Edinburgh, Scotland. His topic of discussion is remote laboratories for effective practical engineering experience. Here in Kenya, we say karibu to mean welcome. So let's send him a warm virtual round of applause. Karibu sana, Professor Timothy D. Drysdale.
Hello, everyone, and thank you so much for inviting me to be along here. I'm completely new to using WebEx, and I'm just trying to work out how to share my slides with you as we speak. So let's see if we can make this work. Right, there we go. That looks like you're seeing the slides. So we've just heard about an amazing technology for communicating huge amounts of data across great distances. So as you can imagine, that's something that's pretty important to me as well, because I have a great application in mind for sending data around. One of the reasons I really wanted to be able to speak today was that the IEEE Kenya section and the University of Edinburgh both share an amazing social mission, and that is that we want to make the world a better place. Now, sometimes we express this in different ways, but things that we do agree on are that it should be sustainable and it should be equitable and open to all. So the spoiler alert for today is that there is a software infrastructure that I'm working on which will address a whole bunch of these things. And I'm going to come back to the meaning of this bit, but this is just to guide your expectations. So this is a bit of a classic quote from the world of science fiction authors and so forth. The future is already here. It's just very unevenly distributed. So where you are might determine how far into the future you are or not. And in terms of education, this raises a very interesting point. You might not actually want to be in certain parts of the future. That's possibly a controversial viewpoint, but as some of us are finding, commercial education technology is doing some awful things. Typical characteristics include having cultural values that don't actually work for you. We have some North American software. It doesn't even work with some of the UK cultural changes, let alone working all around the world. It doesn't do things we want it to do. I can't extend it, I can't modify it because it's closed source. And some of the things we use in the higher education sector around the world are actually taking our students' data and selling it. Just going to close a little window here, hold on. You'll all laugh, but it's about 22 degrees Celsius in Edinburgh today, which pretty much amounts to this melting the entire city. So I had my window open so I didn't melt. But for you lot, I'm sure that is not anywhere near as impressive as we think it is. So across Edinburgh, people are having ice cream and ice cubes to try and survive. Anyway, this should hopefully be a bit quieter now. I happen to have had conversations with some EdTech suppliers who say they actually want to replace us. So, you know, it's a pretty interesting world we find ourselves in now. Is that the future you really want? On the other hand, as academics, we tend to talk about freedom, inequality, transparency, diversity, inclusivity. But can we say that we genuinely live these values if the technologies that we choose to either develop or use are using the other sorts of values that we've just described on the previous slide? Gets a little bit questionable. And things get even trickier when we start looking at practical work in education. Why is education important? Well, I want to unlock the global potential of science, technology, engineering students around the world. We all do. That's why we're in the higher education sector. And if you're a student, that's why you come to a university. You want to unlock that potential. And for practical work, well, you have to do things by doing them. And learning them really doesn't happen without some kind of doing. So if you have some kind of need for something beyond a standard lab, and I'll get into why that's important in a moment, waiting for commercial ed tech, despite all of the negative stuff about it, might not even be an option because maybe the market that we're in is too fragmented, too difficult to address in a way that will make money. So as academics, there's probably two good reasons to take action. One, our values, and two, getting what we want. Do we really need practical work in our degrees? Now, funnily enough, this is really hard to prove. And the answer that I feel in my bones, and I'm sure pretty much all of us feel, is that yes, it is. Now, you might talk to the odd accountant who says, no, it's not, or the odd administrator, but it's really important in my view that we have practical work because, quite frankly, does the world still need hardware? Yes, it does. Are we still trying to produce engineering graduates that develop hardware? Yes, we do. Are they going to have to do something practical while they're doing that? Yes, they will. Should they have some experience of that during their degree? I would say they need a whole lot more. So let's look at the history of practical work. It's really only a couple of hundred years old in terms of its involvement in degrees. So if we go back to the 18th century, we have the lecture demonstration. And this was partly a result of funding. Everything comes down to funding, right? So if you have a salary paid to the person that's giving the presentation and all experimental apparatus must come from that salary, then the most efficient thing to do to be able to afford your mortgage payments and your meals is to do a lecture demonstration where you buy one piece of equipment. However, student feedback started to indicate that this wasn't the most desirable thing from the student point of view. So around about 200 years ago, a couple of chemical engineering courses started to introduce, or chemistry courses, I should say, started to introduce practical laboratories. And this only came about when the universities decided to fund the laboratories separately from the academic salaries. But this might give you a bit of insight into why practical work has had an interesting development and some of the reasons why it occupies the place it does in our curricula today. What are the problems with practical work? Well, we have an awful lot more people now. And some universities, such as the one I work at, have campuses that are developed for a much smaller population. So we often have approaches that were set up that kind of just worked by accident, because if you have a room with some equipment in it, you put some people in it, they're going to do the right kind of stuff. Now we're compressing that. That's an issue. So what you tend to find now is that you have amazing staff doing incredible events, lots of really cool interactive stuff, but it can feel a little bit too much like it might be at the information end. So, you know, that's pretty good, that's pretty valuable. But we're limited in what we can do with laboratory space for various reasons, but sometimes it's just simply a lack of space. So you have a square meter hour. There's a certain number of square meter hours a university might have. What do they do with them? A couple of universities in the UK have made massive investments in absolutely fantastic buildings. They're absolutely awesome. I know the people there, they're doing brilliant work. And even then, the amount of extra practical work you can do doesn't always increase when you have a new building. For one of these buildings, it's gone up. For one of the other ones, it's more or less maintained the same number of hours of practical work. They're both fabulous buildings, but the thing is, that's really expensive, and you need the space and you need the money, and not everyone's going to get that. So if you do manage to do that and it moves you further towards the experience, that's a good thing. If it doesn't move you that much, maybe there are some alternatives you might want to consider. The University of Edinburgh, where I work at the moment, we have an ancient city. We have the university campus spread about in all sorts of little nooks and crannies all around the city, as you can see from these red pins. And that means we are facing the same challenges as a number of other universities around the world are, which is we have a lot of students. How do we get them engaged in engineering? How do we do cool stuff with them without blowing the budget? Because at the end of the day, money exists and we need to respect its constraints. And we also have these aspirations to do amazing educational careers. So I have been working with a number of colleagues around the UK and now internationally to figure out a solution to this. And there are others working in parallel projects that have similar views on the value of remote laboratories. What we're doing that's a little different is looking at the broadest perspective of international federation and combining that with some social and humanistic studies to really start to dig into interesting things about the interactions of humans and objects. Maybe a little bit more on that later. This is a paper that has a bit of my background thinking in it. The slides, of course, are available if you want to email me, and you can get a good written background to what I've been saying in that. So what are we proposing? Well, digital alternatives, real equipment that you access online, or simulations or data sets. And these actually have some cool additional things that are benefits. It's not a poor person's replacement for in-person work. It's actually a different thing that does other good stuff. In my previous employment, I built a £3 million remote laboratory that did a lot of really cool stuff. You can have a look at it at that link there if you wish. We did win a bunch of awards for it, which was great fun, great return on the huge amount of effort that we put in there. But in doing it, I did learn a couple of things about what it's like to have a big project, and that raised the barrier to participating. You know, to do it the way we did it, you did need a lot of money. Could it be done in a better way where you could get involved with the kind of money that we all have, rather than the kind of money that you only get if you get a special project? So that lab did work very well. You know, it was, at the time I was based in Milton Keynes, you could do a demonstration in Austin and it would just run super fast. So I'll just show you a quick thing here. You see when I click on the dial on the left that even though I was standing on stage in Austin giving a live presentation, it looks almost instantaneous. And that's down to all of the cool work that people like the previous speaker are doing on making sure the data travels around the world fast. So problem we have in Edinburgh, and many universities have, is that we want to put labs into a campus that doesn't have room for any more labs. So what do? Well, we can put stuff in boxes, and then we can hide it in nooks and crannies and corners. But it means we need a totally different software system. But these are some very, very rough numbers that I made up the other day, and they need to be changed and you know, made a bit more consistent. But basically, for very, very inexpensive numbers, you can actually give somebody additional practical work that you couldn't give them in the in-person laboratory because it's already full with other cool stuff, for a pretty reasonable price. It's just here as an indicator. These aren't sort of official numbers by any stretch of the imagination, but it's just to say, look, it looks a bit techy, but actually there's a way to do this that's inexpensive. And by doing it in an inexpensive way, you can increase the total amount of experience that you're offering somebody, and that is going to move the dial on the overall balance in their practical work. You've got to keep the core fundamental in-person stuff, but you can now start embracing a world where there are digital alternatives. And even better than that, what I would absolutely love is if we have a worldwide federation where everybody around the world is building experiments that suit their own local culture and practice, and then we get to share that diversity all around the world. Let's get rid of this north-south thing. Let's just all get together and start sharing experiments. The system I need to work across my campus works pretty much around the world as well, so we're heading in that direction anyway. The way I've done it is to build a software infrastructure that takes care of all of the connection. All you need to do is put your experiment somewhere where it can see the internet, and if from that connection you can access a web page, then you're good to go in terms of hosting an experiment. So that's reducing the barriers to getting started. One of the other barriers, of course, is as a staff member, you don't want to have to learn to do digital education. You just want to go somewhere, select a bunch of experiments, put them on your course. And that's an aspect that we're working on this as well, so that you can retain your expertise in your topic, and with a click of a few buttons, make it possible for your students to access really cool experiments online in their browsers. Equally easy for them to access them. All sounds very good though, doesn't it? But can a remote laboratory really replace in-person practical work? Well, it can't replace it, but it can do a whole lot of the same stuff we already do in the in-person format and complement in-person work. If we dig into the intended learning outcomes from a laboratory, most of them we can find a way to do online. A couple of them we can't. For example, sensory awareness. Can you smell that your circuit has short-circuited? Well, yes, you can. Hold on a minute. What if you've got the Mars rover and you're over in space and something's gone horribly wrong with it? Maybe a motor's vibrating too much. Can you tell from the way the camera is moving around that you've now got a vibration issue? So sensory awareness in a modern world where a graduate has to learn to work with remote systems might actually mean learning to work with remote labs. So it's a moving target what we're facing in education, and that's why there are some cool opportunities here. There is educational research to show that the benefits of practical work are at least as good as in-person practical work for those subjects that meet the intended learning outcomes that could be translated online. So that's a positive. And there are some great opportunities for doing things with the rich data stream flowing between students and the staff and the equipment. Things like guiding students out of hours with a little bit of artificial intelligence, or helping students develop evaluative judgment, or simply by having more experience with remote laboratories, you give students an opportunity to do reflective assessment. And I have a mission to turn our campus into a science museum and turn campuses around the world into science museums to increase the magical factor of being on a university campus. Let's make them really cool places. Someone comes to visit you, they can pull their phone out and interact with your latest research or teaching object in the corridor while they wait to speak to you. Or they could do it from around the world. We've been doing some initial development of experiments at the University of Edinburgh, and I've got 50 experiments in a room. We've used 20 of them on a course with 200 students who were earning 80% of their third-year mark with them. And if we are going to be able to do the transition over to David giving us a demonstration, then with all the fun and games of screen sharing, I'm rather hoping that David can show you around a little bit.
Sure. Can you hear me? Yeah.
We can definitely hear you. While you get your screen set up, I am going to stop sharing, and I'm going to answer the question about, is there a public API? The situation at the moment is that all of my software is completely open source, and I'm happy to share those links with you. The development status at the moment is that I've got a system that's running in Edinburgh, and we're sort of quasi in a stealth mode at the moment, but this is why I wanted to talk to you now, is because I want to build collaborative links all around the world. I'd love to develop some collaborative links in Kenya, and part of that will be developing the management tooling to allow different universities to share the equipment on the same network. So the short answer to that question is yes, and the longer answer to that question is the timing around that. I'd be delighted to talk more with you about that offline. Okay, over to you, David.
Okay, and you can see my screen, yes?
Yes.
Okay, afternoon, everyone. As Tim mentioned, I'm a PhD student working in Edinburgh, working along with Tim on remote laboratories. And my main focus over the last year, I'm just in the first year of my PhD, has been on designing new labs, but also the user interfaces of these labs. And down the line, I'm going to be pushing further and further into what we can do educationally with these remote labs by altering the user interfaces. So this is a first iteration. It's the first user interface I've designed for the Controls 3 course for our third year undergraduates at Edinburgh. So I'm just going to give you a very brief overview of what can be done on this user interface. So you can see straight away on the screen, we have our remote lab setup. So this is a DC motor, and there are many different modes that can be put into, well, 3 main ones, and then tuning of those modes. The main tasks that students will be doing with this lab really is looking at a PID controller, so how we can control position and velocity of this motor. And it can also just be used to look at the motor characteristics as well. If I get it running, we should see very quickly I can input a voltage I want to set this motor to, and almost instantly we can see the motor start to spin, and we can see data being presented both in the live stream here of data and collected on this graph that can be used for more analysis later on. The graph tool itself allows students to kind of highlight different areas, calculate gradients, things like that, and also plot functions, which I'll demonstrate in a second. Is that okay? And I'll just demonstrate one kind of use of it. So again, students looking at motor characteristics will have to calculate theoretically what the characteristic might be. So they can run the motor, stop collecting data when they like, and then they can input their theoretically calculated values to check against the actual motor characteristics. So I've hopefully got some correct or close to correct values in here already. Let's pop it in, and then they can plot. I was not too far off. Plot a theoretical curve for the step voltage against the one that they measure live from this remote. It can be put into a few different modes as well. So we can also look at the position PID controller and things like that. I can set the motor to specific angles. I can change my PID parameters, and we can plot the step functions for a PID controlled motor and things like that as well. Similarly, we can plot the theoretical curves. If students want to just play around with this data freely, they can download a CSV of all the data that's being collected and then use that in a spreadsheet somewhere. They can also analyze a bit further using tables of data on the UI as well. For instance, if I want to know what was going on in the motor at a point on this curve, I could jump to this and it would tell me what the command and the drive and the error calculated at that point was as well. In an attempt to try and get students interacting more with the motor and the experiment in general, I'm trying to introduce things like UI tools. So rulers, for instance, for measuring diameter of the disc. This has been scaled so they can calculate the inertia of the motor more easily, and protractors and things for other experiments in our fleet, for experiments that we're setting up. I think that's a brief but in-depth enough introduction to the user interfaces that we've been designing for these remote labs. And hopefully you can see that this gives students a good experience of data analysis in particular and data collection overall. Okay, back to you, Tim.
Magic. Thank you very much for that demonstration. Just get the old slides back up here again. So one really cool thing to mention is that you don't have to be some kind of legendary Facebook experience programmer to knock up a user interface like that. It does require a little bit of learning some digital technologies, but the stuff that we've been doing here is all predicated around it being really accessible. An Arduino, open source toolchain, inexpensive microcontroller, Raspberry Pi, inexpensive computer, mostly open source, Linux, open source operating system, 3D printing, laser cutting, and so on and so forth. So it's intended to lower that barrier to you creating what you want to create. Just a couple of closing comments. Sometimes people worry about what happens if we add too much technology into education. And this is a little bit facetious, but I love this comment. Any teacher who can be replaced by a machine should be. In other words, it's saying if as a teacher you're doing something that is a bit mechanistic and really could be automated by a computer, now's an opportunity to start doing something additional that's kind of cool. And the corollary to this, and the reason why us as humans should never feel worried about technology in the educational space, but should embrace it, is that it's not that humans are better than technology. It's that humans and technology are different. They're fundamentally different constructs. And there's some amazing research going on by my colleagues in Edinburgh about playful technologies that interact with students in an authentically, I'm a piece of technology, I'm not pretending to be a human kind of way. So one of the strands of our research is all about what this technology actually can be like as an agent in the educational process. It's not about trying to replace a human. Humans will always matter. Use cases for laboratories, there's quite a few of them. You know, I've used them as demonstration objects and lectures. We've used them for reports for assessment. We can see them as being really great ways of allowing a student to confront a critical threshold problem and realize that the theory does actually suggest something different than from what their intuitive model built up during school might mean. We're aiming to develop laboratories that work at all levels of education, and they're even great for public engagement or showing off research, things that you've done in your research team. So really, there's a lot of uses there. Core home for me, of course, is the higher educational uses, but all of the other use cases are there and available with pretty much the same infrastructure. Where does that take us? Well, as a university, you often find you've got the academics, you've got an increasing amount of educational technology being brought in, and you have learning technology developers who are there to deal with the manipulation and maintenance and use of that technology. The future that I see is us as academics, instead of spending that money on support contracts with external edtech, we spend it on bringing in learning technology developers that work with academics to develop the things that you need. You know, we have technicians and workshops that build experimental apparatus we need in teaching. Great, let's add to that by bringing in people who are doing the same role as the workshop developers, but developing with digital. And even better, let's bring in student co-creators. Let's have students design experiments, possibly build them and use them, and make this open for all. Now, there's a question about scaling here. The scaling is a really interesting question. You can have multiple users of the same experiment, and there are some interesting pieces of research to do there around how you manage control over things simultaneously, particularly if there's variable latency and then do you pass a token to somebody to give them the control, or do you simply allow a bit of a free fall? In terms of how many people you can just show a video to at the moment, just a single instance of my video relay server is easily chugging through 375 megabits a second of video. That's 20 videos in, about 300 out. That's actually the limit of my fiber optic cable here in my house in Edinburgh, running to my server down in London and back to me. And that's sitting there at probably, you know, less than 25% of the CPU on the Amazon server that I've got set up. So if we wanted to scale that up to, say, a demonstration to, you know, a couple of thousands of students, then we might start thinking about building an architecture that can fan that video out to multiple exit points. And it's all fairly standard technology, and it's something that's on the roadmap to integrate. So I'm pretty confident about the scaling side of things, and I'm building it to be a peer-to-peer system that will scale to having many users. Right, what are some opportunities? Well, look, if you're an educator, if you're a learning technology developer, if you're a student, if you're a graduate, if you're thinking of almost anything to do in this space, there are some really cool things that you can start thinking about doing. There are going to be great opportunities in this space, regardless of the ecosystem that you choose to work in terms of being able to do JavaScript for interactive things, whether it's simulations, we do simulations as well, whether it's, you know, accessing pre-recorded data, something we do as well, whether it's live stuff like this. Now, focusing on the live stuff, because that's the hardest thing to do, and it's also super interesting. So if you can build electronics, hardware, firmware, then you can communicate with the browser. The communication is simple. It's just a JSON text message. Commands and data go backwards and forwards in human readable format, self-describing data. And all of the complexity of joining things up is kind of hidden by the infrastructure. So developing some digital literacies in these areas, I think, will lead to some very rich career opportunities for a large number of people as we move on. There's plenty of room in this space because this is yet to go mainstream. So if you start working in it now, you'll be part of taking it mainstream, and there's some great opportunities there. So in summary, why do remote laboratories? Well, it's going to save us some money on expanding the amount of practical work we've got, but it's also going to bring us new pedagogical opportunities, which will allow us to improve the type of education we do and continue to advance far ahead of all those commercial ed tech people that want to take our business away from us. If we don't do them, we are going to have issues with time, space, and money in terms of the amount of practical work we can do and what our accreditors might say about it. And my passing call to action is, this is a very young system. I've got great ambitious plans for its growth, and there are some brilliant opportunities coming up. I am almost 100% certain for us to do some collaborative work together, and I would welcome contact from people who feel like being in the early adopter shoes and getting into the messy details of the software over coming years. So do feel free to have a look at our website. It's a very, very early stages. We're sort of in a quasi-stealth mode, so you're getting a bit of a special preview here. Drop me an email if you want to copy the slides. If you want to try some things out, drop me a line. We can send you a link. And if you want to start working with experiments, we can certainly facilitate you having a bit of a go with our infrastructure as well. Things will get easier and easier to use as we go along. And for now, we're just really excited to be able to start showing that we've got some cool stuff happening that's going to help us bring a sustainable education that's affordable for everybody, and it's customizable to suit the kind of culture that is in place in your institution and in your country, so that we can have a really diverse and interesting world. And quite frankly, I am super looking forward to seeing all the cool experiments that are being developed around the world, and be able to bring those flavors into the education that we do at Edinburgh. So, it should be a great, great opportunity to share. So thank you very much for that, and I wish you all the best for the rest of your workshop.
Thank you so much. My connectivity. Thank you so much, Team Drysdale, for such a wonderful presentation. Maybe we can look at the questions that have been, there are so many comments that have been given. One of them, it says, I see it is an excellent contribution to visual programming, which is very nice to see the students setting up the labs and running them.
Yeah, there's some amazing stuff we can talk. Well, it's a really interesting comment. It's a really insightful and perceptive comment. There are a couple of things that we are either already doing or targeting doing that that this kind of unpacks. So to unpack it a little bit more, one of the things about a remote lab experience is it's often in its current format around the world fairly prepackaged and fairly constrained. And one of the things that David is going to be exploring is ways in which you can make that much more free-ranging, open-ended, and exploratory. So we've got some great ideas about how to do that. The other one with programming and the visual programming is that with languages like Blockly, which is kind of like Scratch, but for any other language you wish, you can bring in a Blockly programming chunk, and you can either have a simulation. We have a solar panel that our first years have to control to follow the sun, and they have to program it in Blockly to read light sensors and then control the motors in this virtual simulation. And that all happens simulated, but sort of live simulated. So there are great opportunities there. And something we're working on right now is a way to allow students to do bare metal programming of the Arduino at a distance, whilst we can keep the equipment safe by putting a supervising circuit in there so that they can't accidentally energize two things that would make a short circuit or burn something out. So that, which is particularly important for IEEE minded education courses because of the incredibly important role that embedded systems programming plays in the future world. So, I mean, that's a really insightful comment, and it's bang on the line of, some really cool stuff that we're doing. So thank you to the person who made that. I believe that was Isaac. Thank you, Isaac.
Yes, there's also even a question.
Yep.
How does it scale in terms of number of students that can run the same lab concurrently? And what are the collaboration avenues?
Fantastic. So I sort of answered the first half of that very briefly. At the moment, the number of students that can run the same lab concurrently, effectively, you can make a decision as an educator, do I want to allow one experiment per person at a time? Or do I want to allow groups of 2 or 3? Now, sometimes we have students work together on equipment because we don't have enough equipment to go around. Other times we have students work together on equipment because we want them to learn teamwork. With remote laboratories, we get more hours per day and more equipment hours per student in total. And so we can actually actively choose, do we want to have group working tasks or individual working tasks? We find that the optimum number of experiments is around about 10 per 100. I've got an MSc student working at the moment on doing some number crunching on different statistical analyses of booking patterns and task requirements and numbers of equipment available. So for our 250 students, we actually had 12 pieces of equipment running all the time, and we had a few in backup. Ideally, we probably would have put on a few more, but it depends on how spread out the equipment is. So you could have multiple people running the same experiment concurrently. If it was only doing 15-second batch jobs, you could have, hundreds of people all just putting their little requests in because they're little at 15 seconds, and the system will just fire through them and it will feel like they're running concurrently. So there are lots of different ways of slicing and dicing this. As for collaboration avenues, well, this is an interesting one. So we're at a really, really early stage, and I haven't yet set up proper documentation to help people learn how the system works and so on and so forth. The things that we're doing are all open source, so all of the details are there to look at, and they're on GitHub, and you can see them by going to the website link there. There's a link down the bottom to the GitHub repositories. We're going to be doing a better job of making this accessible and easier to onboard. So in the first instance, if you're interested in getting stuck in, drop me an email and we can have a bit of a chat about what it is you would like to do. Potential collaboration avenues include you starting to develop your own experimental hardware and then trying it out by connecting to my service here in the UK. Another option is to take the same server software that I have and to run that up on computers that you might have in your own university, or on a local instance of a cloud provider, and running your own separate version of the system as we do at the moment. Now, those separate versions won't talk to each other at the moment, the current version of the infrastructure, but inbuilt into the way I'm doing things is flexibility to allow the system later on to be very, very directive and say, right, you need to connect this video to that person, but not this one, and so on and so forth. So we've got that flexibility coming because we're putting the right blocks in place. So for now, working on custom experiments is probably a pretty interesting place to start. If, on the other hand, you're really into web services and doing some programming in Golang, then I've got server development stuff going on, and more than happy to discuss the nuts and bolts and bits and pieces of that with anybody who wants to as well. And then we've got the user interfaces. So right, moving on, what are the other players in space and maybe collaborators and competitors? So at the moment, there is the Global Online Labs Consortium, there's the Doisto Web out of Spain. They've got a commercial thing called Lablands. The situation with a lot of remote laboratory projects is that they got funded with a big chunk of money. There's David Lowe down in Sydney, he's done some amazing stuff as well there. You get funded with a big chunk of money, you target a certain number of courses, you build your labs, and then the money runs out and the people that you hired go away. And then you carry on maintaining what you've got. So quite a lot of laboratories suffer from a sustainability issue. So one of the reasons that I'm building the system the way I'm building it is that I want it to have an architecture that would be able to be sustainable with the annual teaching budget that you get on a course at a university. If that's £500 to buy an experiment. Yeah, one of our experiments is about £500 on average at the moment. We've got plans to try and get that down to around about £50. with some limitations in video data rate, obviously, but the idea is to get that down. So there are other competitors out there. I feel that the unique selling point of the approach that we're taking is that cloud native peer-to-peer ambition that we've got from the beginning, and the focus on making this something that's accessible around the world. So we've got a lot to do to actually implement on all of those promises, but the way that you start a project off can often determine how far you can go with it. So we're building for the long term. We're planning to grow slowly but stably, and to be open all the way. So everything we're doing is open source and there for you to modify as you will. So hopefully that helps, gives you a flavor. The main thing is remote labs have to go from being niche things as they are now to the mainstream. And so my focus is on trying to get the friction out of the experience. You just go to a browser. There's nothing to download. You just use it in a browser. And as a staff member, ultimately it will integrate into your learning management systems, and it should be simple to set up.
Okay, thank you. Maybe in the interest of time, you can answer the questions quickly. Is there a public API?
So the public API, so at the moment, it's public by default, but at the moment, the booking system is, what's the word? It's a public API in that anybody could access it. I'm currently holding the access permissions to those, and setting up a system where we can all have our own domains of experiments that we run is on my roadmap for this year. So at the moment, if there's experiments you want to set up, get in touch with me and we can set you up the link into our server, and you can start gaining some experience, and then our infrastructure will come along and make that a much easier process. My goal at the end of this is that to try and avoid that issue of you having to email me or having to email the person that runs whatever remote lab system it is, and just be able to go to a web page and go, yeah, I want to do a remote lab, and just have it happen. And so we're at an early stage. It's a long road to get there. But that is what we're targeting, because we want this to become mainstream. So if you want to become a part of this, the best thing to do is just get in touch. We can have a bit more of a talk about where our system is at, what your aspirations are, and we can work together on finding funding to scale up the activity, or just to work informally on the things that are of mutual interest. So I'm looking forward to hearing from you. And we're at early adopter stage. If you're looking for a polished, ready, finished product that you can just roll in, we're not there yet. It will be a little bit of time. If you're interested in the nuts and bolts of how things work, and even are interested in having a bit of role in how things develop, then now's a good time to start getting in touch.
Thank you so much for your insightful session and for answering our questions. We really appreciate your participation. A warm round of applause for him. Thank you so much.
Thank you all for all of your insightful questions and your attention. It's been a real privilege to be able to join you today, and my many thanks to Stephen and the other organizers for making that possible.
Thank you. Thank you.
Hi, can you hear me now?
Yes, you can,
Hello?
Fiona.
Oh, okay. Carrie was just here. I'm not sure if she's back. And she was here at around at 40. I don't know if she's back. Okay, I think she left. Yeah, she was here some 10 minutes ago. She was ready to start. So apologies on our side. It took quite some time. I think she dropped, but we will try and get back to her and see when she can address us. So I think for now we'll head over because the workshop, the IBM workshop starts at around 3 p.m. So yes. Yeah, the workshop starts at 3 p.m. So we are going to share the link with you in about 2 minutes. So for the IBM workshop, they requested us to use their platform, Crowdcast. I don't know if you people have downloaded the Crowdcast or if you have the Crowdcast desktop app. So, so we are going to share with you right now the link. So just be patient. We're so sorry. Carrie was here with us. She was here trying to put it. She was ready to start, but because of the overflow with the program, I think she dropped out. But we'll get back on that. So let me just share with you the Crowdcast link right now. So the technical team is here to help you with anything that you need. So I've shared the Crowdcast link. So everyone, let's just head over there and join the workshop and wait for the workshop to start. So I would need a confirmation from your side once you're on the Crowdcast platform. Just a thumbs up would suffice. Okay, so I see let me just share my screen. Okay. Can you see my screen?
Yes.
Okay, so the session will start in about 1 minute and 37 seconds. On 35, there's a countdown. So just add your email and then just join the event. So it will send you a login link to your email. So you check your email, get the link, and then join. So are we in, guys? Have you managed on your side? Okay, thank you. Just a thumbs up if you've been able to join on your side. So for those who are still struggling to join, let me just share my screen again. Once you, okay, can you see my screen? For those who are trying to get there, this is somewhere you should be. Guys, are you there?
Yes.
Okay, so
We've started.
Let's see. How can Shuri host Node.js front end and probably back end application, right? So she wants to host a Node.js application, React on the front end, and Express on the back end with a database, and share the link of an application she's working on with the client, and she can access it over the internet, right? Typically, today, Shuri has like three options, right? One option is for Shuri to buy our own server. That's a traditional server option. Cherry buys our own server, configures it, hosts the application on it, and connect the server to the internet. But guys, Shuri realized that a server costs almost like $200,000, right? So that's expensive. She can't purchase it, right? And she can't import our server into our country, Wakanda, right? So then, apart from the fact that it's expensive, she also needs the knowledge of server configuration and maintenance, right? Oh, she also realizes that I have to spend a lot of money to maintain the server. I need power running 24/7. I need I need AC, a cooling system. Then she looks at this option as, oh, this is not for me as a young developer, as a student. There's no way I'm going to afford a server myself. There's no way I'm going to buy that expensive server, and there's no way for me to even maintain this, right? Then she she looks at another option, right? Local hosting service, right? Maybe she spoke to her colleagues and they told her that there are some local hosting services in Kenya that she can use, that they are cheap. But these services are not, she doesn't trust them in terms of scaling her application, and sometimes they go offline and they don't even have support for Node.js. They only support PHP websites. You can only host WordPress, and this is so like 1999, right? We should be able to host any kind of application, right? Then third option, right, which is a very interesting option for a young developer like her, the public cloud hosting option. She remembers that she once attended an IBM webinar when they talked about public cloud and how she can host any kind of application. Then she Googles about IBM Cloud and saw that cloud is the way for her to go. And how did she come to this conclusion, right? Because the interesting thing about cloud is the speed. It gives you speed and agility as a developer, right? You can quickly just create a customized virtual server for yourself on the cloud, and or use a managed service option like platform as a service. Really, so you can just go to the cloud and create any server of your choice, whether a Linux server or a Windows server, and you have that like within few seconds. Your server is ready. You don't have to wait for a server to be imported, and you don't have to pay 200,000 K upfront. You pay as you go, right? This is really interesting for a developer. You don't have to pay as you start. And in fact, there are even a lot of free options for her to start with. Then there's flexibility, really, like she can use platform as a service to host the application. She can use containers as a service to host containerized application. And she can decide to go serverless, right? She doesn't even think about server, right? And apart from this, she really has access to a lot of innovative services like AI and blockchain on the cloud that she can embed into her application. And then, of course, she realizes this is really the option for me to go because it's better in terms of cost. I have access to some freemium plans on IBM Cloud. It gives me speed and agility to quickly create test and try out things as a developer. Yeah, so it's really a good option for her. Cloud is the option, right? Then why IBM Cloud, right? She remembers as well that, oh, of course, there are several cloud providers, but IBM Cloud, they have a lot of services in their catalog, over 400 services, and that's growing every day. They have services that tailored for developers, more than 200 API services. She can do storage, can do compute. Then there are softwares as well that already exist in the cloud, like open source software that you're familiar with, like WordPress. You can just use that to quickly create a WordPress application on IBM Cloud. There's TensorFlow, you can use that to quickly create like your AI models and all of that. So she found this really interesting. And of course, IBM has a lot of consultation services around cloud as well. There's Garage to help you innovate in sort of a design thinking model. So then we have cloud migration services. We are helping our clients. When you have issues, there's a support service to get you through it. You can talk to developer advocates, and this like the best option for sure, right? And then in terms of, she then thinks further really on IBM Cloud. There's a lot of flexibility, right? She looks at the options that she has as a developer. You have options to either go serverless, option to use a platform as a service where you pick the platform of your choice. So like either for maybe to deploy a Java application, to deploy a PHP application, you have access to deploy for any runtime of your choice. And there's container as well. You can deploy container-based application. And there's also virtual server or VMware where you can leverage the existing existing image and tools. You can sort of deploy your application on virtual servers as well. And as well, if you want to go the route of a VM meta server where you have control, you have to set up the entire server yourself, install the OS. You also get that on the cloud as well. So it all comes down to your choice, your control, and your consistency, right? So just to let you know, you can always put your questions in the chat, and we have a question and answer section where you can also put your questions. My colleagues would attend to you, and would also have the question and answer section at the end as well. So, like I said, So then she also thinks about IBM Cloud, right? In terms of she likes open source and she's looking for a platform that supports open source. Then she realizes, okay, cool. On IBM Cloud, there are lots of open source tools like it supports a lot of open source applications like Docker, right? Yeah, like so. If you're already used to any these tools on on any cloud platform before, or on any other platform, you can always reuse that same knowledge on IBM Cloud. You don't have to start learning new set of tools. Support the open tools. It's an open cloud platform, right? For AI, we support what TensorFlow, which is an open source AI tool. For container, we support Docker, we support Kubernetes, and a whole lot of other open tools as well. And how does she start? Right now, she has made up her mind. She wants to do cloud. She wants to do IBM Cloud. How does she start? So on IBM Cloud, there are two major ways for you to interact with the IBM Cloud platform. Right? You can either go to your cloud development console, which is the web platform, which is the web link. Now you can access IBM Cloud on your web, on the browser, or you can do the form part, which is using a CLI tool, a command line interface, right? A lot of developers want to use command line interface, so we give that option. So you can either create your project on the web or do command line interface, right? So we have those two options for you. But for today, we'll majorly be focusing on the cloud, right? On the web-based interface that you can use to access IBM Cloud, and then you can deploy your code bring your code from your source code repository, or you can use our starter kit as well. And our starter kit already has a lot of code around Express, Node.js. It has some code that you can start to use. So with starter kits, you don't have to write from scratch. IBM already has like starter kits for you that you can just start to use and make your work faster, right? So these are a lot of tools that you can access on IBM Cloud. So quickly, you also see like in terms of our starter kits, you're able to pick you can able to do basic web app for different kind of use cases that you have. You can do microservices, a basic backend app for Express, Watson app. We have a lot of usable intents for your Watson assistant and all of that, and a lot of startup kits around Spring, Express, Flask, and starter kit for Java, Node.js, Python, Swift, and a whole lot of others on IBM Cloud. So how do you get started, right? So to get started, so today our focus, like I said, will be using the web platform to access IBM Cloud. So at this point, we're going to be sharing a link with you on how you can access the IBM Cloud in the chat. And we'll use that link to just a minute. Please can you share the link in the chat, Subisiso or Mohammed?
Okay. Actually, I'm just sorry to interject, guys. Please just click the green button, right? So the green button on your screen will allow you to create an IBM Cloud account. So just click the green button and you should be good to go.
Yep, there's a green button which says create an IBM Cloud account. Just click on it and you will be redirected. But if you don't want to, I'm writing this in the chat as well.
Okay. Thank you for that. So you'll be required to sign up, right? If you click on the link, but because I already have an account, it will just take me to log in, right? But in your case, you'll be required to sign up with your email address and password. we just take a few minutes to get people to be able to get access to the IBM Cloud platform. Then we'll take it from there. So let us know in the chat when you're able to access the cloud platform. So while we're waiting for confirmation to sign up, okay, we see Issa is already in. If I get one more confirmation, then I'll proceed. But let's keep it coming. Let us know in the chat if you have been able to sign up. Okay, so we'll just proceed.
Can we wait 1 minute more? I think people are signing up. Okay.
Yeah, sure, to do that.
Okay, one more thing that I wanted to remind. So if you're coming from a WebEx call, make sure to mute the WebEx and then focus on the crowdcasting. So in that way, you won't have any echo problems.
Okay, so Mohammed, you can let me know when I can continue once you see any other confirmation.
Sure. Just 1 more minute and then we can continue.
Okay. All right, sure. Oh.
Should we wait or should we go on? Do let us know in the chat. We're currently waiting for everyone to create an IBM Cloud account. It takes hardly 5 minutes. So do let us know.
Okay, sorry, Mohammed, you were cutting. Did you say I can continue?
No. I'm just asking the audience if they created the IBM Cloud account.
Okay.
Okay, you can start now, Tosin, with your next step.
Okay, thank you, Mohammed. So for the next steps, right? So once you sign in, you've been able to successfully sign up or sign in into IBM Cloud, you're going to have this kind of interface that I have as well, that shows you your dashboard, right? And there are a couple of things that we want to pay attention to here, right? The first is the catalog, where you sort of see all the services that are available on IBM Cloud. So let's just quickly go there. We go to catalog, click on catalog in the menu to access catalog. And here you see a couple of recommended services for you. yeah, these are recommended based on maybe your usage, your interests, right? But let's go to explore those options, right? So we have, so you have services, right, which are like services for you to use on IBM Cloud, and as well there are softwares that you can leverage, right? Like softwares like WordPress, if you want to build a WordPress application, or you want to use TensorFlow, Bitnami, a whole lot of open source software available, right? You have access to use them on IBM Cloud as well. So for services, let's go to services. Go to services, and the interesting thing here is that I want to show you a number of services that you can get for free. So when you sign up on the IBM Cloud, you have something called the Lite account. The Lite account gives you access to a lot of free services. And this is why developers are interested in IBM Cloud, because we give them freebies for them to use, right? To try to test in their development environment and things like that, right? So you filter to Lite, you'll be able to see like all the different services that you can use, a whole lot of services that you can use free of charge on IBM Cloud, right? And so you can use, say, API Connect, which is an API tool, an integration tool. You can use, for example, Cloud Foundry, which is a platform as a service tool. You can use Container Registry to host your container image in a private registry on IBM Cloud. You're able to do continuous delivery, to use DevOps on IBM Cloud. You're able to do cloud monitoring. You're able to do IoT, for those of you that are interested in IoT, and a whole lot of AI services that you have access to free of charge, right? You can do language translator, you can do speech to text, text to speech, and you have access to object storage as well, which is a unique kind of storage. You have access to push notification if you're a mobile apps developer, and so you can do speech to text, you can do text to speech. You have access to two chains where you can integrate different types of tools into your DevOps pipeline, right? So these are a whole lot of free services that you have access to, right, on IBM Cloud. By just signing up, we give you all of this for free, right? About 44 services. Then apart from Lite, we also have free, something that we call free. So Lite is free for after Lite. There are some services that you need to upgrade your account by putting your credit card or your debit card, as whichever one that you use, right? And even after you enter your credit card, there are still some services that you can have access to free, right? And you see all the services that Lite, you still be able to access them, plus additional services, right, that you wouldn't have been able to access on just the Lite accounts. So these are lots of free options that you get on IBM Cloud, right? Now let's go to like the different categories to see like the different services that you have. For example, for compute, you can do virtual servers, right? You can create virtual servers on IBM Cloud. You can also create a bare metal server. You can do serverless with either functions or code engine. And you can do Cloud Foundry for platform as a service, where you can deploy any application of your choice, whichever runtime of your choice, whether it's Java, JavaScript, Node.js, Python, and the rest. Then for containers, we have Kubernetes, IBM Kubernetes service, and we also have the Red Hat OpenShift, which is the platform of choice for containerization on enterprise, right? We have Container Registry, which I've mentioned before, and also Code Engine. And for networking, you have access to for people who want to do like direct link to IBM Cloud. Well, that's a bit advanced, but you can also do like virtual private cloud, which you create like a sort of private cloud for your applications in the cloud, and you can leverage a content delivery network to distribute your to make your maybe website faster by distributing your content on the edge, right? Then we also have storage. Of course, we have the block storage and the object storage. We have other kinds of storage as well, like Box. We have access to other external kind of storage. For AI and machine learning, Watson Assistant, which is for chatbots, and Watson Studio, which is like an end-to-end tool for building and testing AI application. And you have access to speech to text, text to speech, and a whole lot of other services, which you can check out, right? Then you can do analytics, you can do blockchain, you can do, then interesting thing as a developer as well, you want to check the databases that we have. We have the NoSQL database, like Cloudant, which is based on CouchDB. We have the PostgreSQL, MongoDB, Redis, and a whole lot of other, like MySQL, DB2, and other databases of your choice, right? Then let's go to developer tools. These are the interesting parts, right? You have access to third-party tools like APIs to get breaking news on IBM Cloud. You have API for identity, to know your customer, things like that. They have API gateway for managing your APIs, continuous delivery for doing DevOps, continuous integration and continuous delivery. Then we have integration with SendGrid for you to send emails in your application, and a whole lot of other services that developers can leverage, right? This is just enormous. It's fantastic, all the tools and services you get on IBM Cloud. Then for logging and monitoring, if you want to do some operations, you want to check, make sure that your application is up and running, we have tools that you can use to do cloud monitoring as well, and log analysis, and a whole lot of other services. Migration, integration, Internet of Things, for mobile development, like push notifications, things like that. So these are several services I can access. Then for software, you have access to a whole lot of software as well, in IBM Cloud. Like I mentioned, there might be some names that are familiar to you, like Apache. You can create an Apache server without having to set up. It just creates it for you using Kubernetes and host it on Kubernetes without having to worry about it setting up. You can host ASP.NET application as well, which leverages Kubernetes and OpenShift. Then let's just see CouchDB, Django. These are things that you're probably familiar with. If you want to host any of those things on the cloud, you can leverage this. We have Dropper, we have Elasticsearch, we have, just looking for the ones that are very familiar, Ghosts, GitLab. If you want to create your own private GitLab, you're able to do that as well. You want to host a GoGen application. You want to looking for other familiar things, Java Liberty app or Java Spring app, Jenkins, Joomla, Jupyter, Kafka, a whole lot of free services, right? Sorry, software, this time software, LAMP, for doing Linux, Apache, MySQL, and PHP application, a whole lot of other softwares, MariaDB, main stack, you want to host a main stack application, MongoDB, MySQL, Nginx, right? A whole lot of services, a lot of softwares that you can leverage. You can go through that in your free time, right? So because of our time, we won't be able to go through everything. So now let's go back. So now we sort of covered like the catalog. Of course, you can't exhaust all the catalog in this call. Yeah, you can always find, and you can always leverage the search to look for to search for whatever you're looking for. So if I maybe search for Watson, it brings out like Watson services for you, so you can see like those different catalog results, like under catalog results, services that you can leverage on IBM Cloud. So so essentially that's about that on catalog. Now let's go back to the home page again. Just quickly show us other things that we need to pay attention to on the cloud console. Now we know like the services. Then how do we see like services that you've created already? Maybe you created something that you want to go back to see them. Here you as well see resource summary. So you're able to see like all the services that you have already, that you've created already on IBM Cloud. And you can view all, it categorizes them for you into like sections like services, cloud training services, apps, developer tools. You can click on view all to see all those services that you've created on IBM Cloud, right? And you can filter them, and all of that. So for me, you see, I have storage that I've created. Maybe I'm using an object storage, or I'm using some Cloud Foundry services. I've created some Cloud Foundry apps. So you can always go back to those services that you've created on that resource list. Now we've seen the services that are available, and we've seen how you can see resources that you are using, but how do we create a resource? And this is where, this will be the meat of this session with me before I hand over to my colleague. Right now, we are just going to see how to create say a Watson assistant resource to create a chatbot for a university, because we are all students. So, and this is something that we can relate with, right? So to do that, there are several ways that you can create a resource, right? For example, if you know what you are looking for already, you can just put in this in search resources and offering and say Watson assistant, because that is what you need to create a chatbot. Sorry, just a minute. So I put Watson assistant, and it brings out the Watson assistant service for me. So I can click on this then to take me to the process of creating. Or you can also see this very nice big button here that says create resource. I can just click on create resource, and it takes you to the catalog. So this sort of helps you sort of search for things. Maybe if I search for chatbots here, yeah, it brings out Watson assistant. So I click on Watson assistant, right, and it takes me to this screen. And yeah, so there are a number of concepts that you should also take note of when using cloud, right? Location. So you need to choose like a location where your services will be hosted. Usually on IBM Cloud, we have these regions, like so it's always good to pick the location closest to you. For us in Africa, it's majorly Europe, London and Frankfurt. Yeah, most time I pick London as my favorite location to host my application, but you can choose any other location of your choice. But yeah, so that's about location. Then you need to select a pricing plan. So for pricing plan, you by default, if it's a service that is available as light, right, which is like a free option, it chooses light for you, right? By default, it chooses light. But if it's not light, it will pick like maybe the smallest plan for you, right? So then there's lights. In this case, there's Trial Plus, Enterprise, and all of that. But light is what I've chosen, what it picks for me by default, and I'm able to do free stuff with Watson Assistant. Then the next thing we want to do is let's make sure we are using a nice name that we can use to identify that service. For example, I want to create a university chatbot. Okay, the university chatbot. Then I type that as my service name. And yeah, of course, for you guys, if you resource group is sort of like a grouping of different resources, but it's just good to leave it as default, and it won't give you any other option anyways, because you probably haven't created any other resource group. Then for tag, we can leave this as it is as well. It's optional, but it's good to tag your application. Maybe you want to have like tags, like maybe it's a development environment, or this is version 1, and all of that. Yeah, so once you do that, so for me, I already have I created a Watson assistant service. It doesn't allow me to create another one because I'm on a light account, right? So I don't want to delete what I already have. So sorry, I'll be able to show you. But in your case, this create button will be blue, so you'll be able to click on it and to take you directly to the service, right? Yeah. So, but I'll just click on view existing in my own case. But if you click on create, it takes you directly to the service. So I'm going to click on view existing, and so let me know if I'm too fast. If there's any comments about that moment in the chat, so that I'm at the right place.
Not at all, but I'm just monitoring the chat. I will let you know if there is any question.
All right, cool. Thank you. So yeah, we want to in my case, I already created a Watson assistant, but in your case, you will get to this same screen as well, where if you click on the create button, right, it takes us to the same screen. So once you click on the create button on your own end, right, it takes you to this page, and then we want to click on launch Watson assistant. So that's sort of the next step. So I click on launch Watson assistant, and it takes us to a Watson assistant service instance where we now can now start to do some interesting stuff with our chatbot. So it's taking a few minutes to load.